Hey everybody, welcome back. Alright, so we are going to keep exploring ways to solve quadratic equations. And, okay, so this next one you may have heard before, and some people have some variety of views on this. It's called completing the square. And it's going to lead us to the quadratic formula. And a lot of people just use the quadratic formula, but this is really how the quadratic formula came about. And that's when, in fact, this was used by the ancient mathematicians, even going beyond the ancient Greeks. The Egyptians knew of this, and Mesopotamians and stuff, and they did this method. So we know that it's real nice if your equation just consists of something squared equals a number, and you can just take the square root of both sides. And in particular, it would be kind of nice. Well, it would be nice if it was just an equation like x squared equals 5, but probably the next best thing would be x plus a number, that whole thing squared, equals 5. Okay, because we know how we can do that. And this method of completing a square allows any time you have something in the form of x squared plus some number times x, you can actually transform that into something squared plus or minus some number. So the way we do this is we just have this identity here, x plus b over 2. If b is just a number, x plus b over 2 quantity squared. If we multiply things out, we get 1/2 bx plus 1/2 bx is just bx. And b over root times b over 2 is b squared over 4. And of course we can rewrite this as b over 2 quantity squared. So the quantity is, if you add the right number, then you get something which is something squared. Okay, and this is called what we call a perfect square trinomial. Okay, basically. So the thing is, that's the idea, that if you can find some number, whenever you have x squared plus a number times x, you can add some number c that makes this in this form. And we can see it's exactly what we just basically see in all these cases. C is going to be b over 2 squared. Okay, or I'm sorry, just b over 2, b over 2 squared. So in this case, like b, where b is the coefficient of the x term, okay, for x squared plus bx plus c. Okay, this will be a perfect square as long as c is this number. So in this case, b is 12, so b over 2 is 6, and b over 2 squared would be 36. Okay, and so c is going to be 36. And in fact, we can check that x squared plus 12x plus 36 is in fact x plus 6 squared. Okay. Okay, if you multiply this out, that's what you get. Likewise here, in this case, b would be -7. So b over 2 would be -7/2, and b over 2, so c would be -7/2 squared, which would be 49/4. Okay, and you can check that x squared minus 7x plus 49/4 is in fact x minus 7/2 quantity squared. Okay, and then here, so the b can be doesn't have to be a whole number. B is 2/3, so b over 2, that's the same thing as 1/2 b, which is 1/2 times 2/3, which is 1/3. So b over 2 squared, well, c is b over 2 squared, so this would be 1/3 squared, which is 1/9. So that would be that, and you can check that x squared plus 2/3 x plus 1/9 is in fact x plus 2/3 quantity squared. Yeah, 1/3. Sorry, 1/3. 1/3. Okay. Okay, so how can we use this to solve quadratic equations? Well, let's do the same. Let's do that. So we said that if we have x squared plus 12, let's look at an equation like this. Notice that x squared plus 12x, that's the same thing we have up here. And if we add 36 to it, then this will become a perfect square. So let's add 36 to both sides. So what's going on here, again, b is 12. b over 2 squared, we said is 36. So add 36 to both sides. And then this, we know this is just x plus 6 squared. And this is 46. And so now this is an equation we should know how to solve, right? We can just take the square root of both sides. So this is going to be plus or minus the square root of 46. And then subtract 6 from both sides. And you get x is going to be negative 6 plus or minus the square root of 46. Okay. So that's how we can do this. This is called completing the square. And that's how we do this. Okay. So let's just look at a few more examples then. In this case, we have x squared minus 6x. All right. So we have, in this case, b would be negative 6. b over 2 would be negative 3. And b over 2 squared would be negative 3 squared, which is 9. Okay. Now, notice that there's already a 4 over here. So what I can do, depending on what you want to do, I'm going to just take the 4 out of the way here first. And so I subtract 4 from both sides. Now I'll add 9 to both sides. And now this then will factor as x minus b over 2. That's a x minus, let's see, so b over 2 is minus 3. So x minus this will be, x minus 3. Yep. So, actually, with x plus, but you can see. So this x plus b over 2 is going to be, in this case, it will be b over 2 is minus 3. So the minus 3. Okay. And then this will be 5. And then I'll just take the square root of both sides and get x minus 3 is equal to plus or minus the square root of 5. So x will be 3 plus or minus the square root of 5. And you can just leave it like that. Okay. All right, so we did the 4. You just have to move the 4 over here and then go ahead and complete the square. Okay. We want to do another example. Here, the coefficient of x is 1. Okay, so b is 1. So b over 2 would be 1/2. And b over 2 squared would be 1/4. Because that's 1/2 times 1/2. So we'll add 1/4 to both sides. And then this will factor as x plus b over 2, so this will be x plus 1/2 quantity squared. And this is going to be, 3 can be written as 12/4. Okay, so this will really just be 13/4. And I'll take the square root of both sides. and then subtract 1/2 from both sides. Okay, now this would be okay, or if you want to, you can notice that this is the same thing as square root of 13 over square root of 4, and the square root of 4 is 2, so this is the same thing as negative 1/2 plus or minus the square root of 13 over 2, or if you want, you can write it as negative 1 plus or minus the square root of 13 over 2. Okay, either one of these is fine with me. Okay, it might not be, your computer might be a little picky, but I'll show you that's how it works. So yes, you can do this with fractions as well. There's nothing says that you could. This only works with. You can do this with, as long as you're willing to work with fractions. Then it's no problem. Okay, there's a couple more examples. Here we have. Now we have a kind of a more normal, regular, another quadratic equation. And of course we can take the 7 to the other side by adding 7 to both sides, right? Okay, now the only thing that's different here is we have a 2 here in front of the x squared. Okay, so we need to take care of that 2, deal with that 2 before we go ahead and complete the square. Because this completing the square business will only work if you have an x squared by itself, not 2x squared. So we can get rid of the 2 by dividing everything by 2, or multiplying everything by 1/2. Same thing. So this will be x squared plus 3/2 x equals 7/2. Okay. And now we can, in this case, we have x squared plus bx, where b is 3/2. 1/2 b will be 3/4. Okay, and 1/2 b squared, or b over 2 squared, will be 3/4 squared, which is 9/16. Okay, so this is what we want to add to both sides. We don't want plus or minus yet. This will just be, no, so 7/2 plus 9/16. Okay. Okay. And then this will just be x plus 3/4 quantity squared, because 3/4 is b over 2, or 1/2 b. And over here, this is going to be, if we get a common denominator, it looks like we need an 8 here. Multiply and divide this by 8. This is 56 plus 9. That'll be 65, I think, over 16. Okay. Then we can take the square root of both sides. And you'll see that we have a perfect square right here, so we can, the square root of 16 is 4. So this is the same thing as plus or minus the square root of, well, I'll just write it down here. And then subtract 3/4 from both sides. Which will be negative 3 plus or minus the square root of 65 over 4. All right. Okay. And again, you can use your calculator to figure out what the approximations are. But this is the exact value. Let me just do one more example here. If we try to do the same thing for this one, 5x squared plus 3x plus 7, let's take the 7 again to the other side. So we'll have 5x squared plus 3x equals negative 7. We have to subtract 7 from both sides. Now we'll divide everything by 5, or multiply by 1/5. So this becomes x squared plus 3/5 x equals negative 7/5. Okay. And now we complete the square. B is 3/5. So B over 2 is 3/10. You can check that when you multiply this by 1/2, you get 3/10. And B over 2 squared would be 3 squared over 10 squared. So that would be 9 over 100. So this is what we're going to add to both sides. Okay. And on this side then, this becomes x plus 3/10. Could be over 2 is 3/10, so this is x plus 3/10 squared. Now over here, if we get a common denominator, we're going to have to multiply this by 20 and this by 20. So we'll have a denominator of 100, and then this will be negative 140 plus 9, which becomes negative 131 over 100 equals x plus 3/10 squared. Okay. Now, at this point, if you stop, take a breath, stand back, and look at this, something's funny, right? Because if we try to take the square root of both sides, we have a problem because we can't, this is a negative number, okay? And we're saying that a negative number is equal to something squared. Well, a negative number, there's no, if we're taking this to be real, x to be real, if this is a real number, any real number squared has to be 0 or positive, okay? So at this point, we say there's no solution, because we can't take the square root of a negative number, all right? So that's why you want to keep in mind. You know, if you went ahead and took the square root of both sides, again, and you try to plug this in your calculator, you get an error message, right? But hopefully you can recognize here, once you get something squared equals a negative number, there's no solution as far as the real numbers is concerned. All right? So try this, and then in the next section, we're going to show how this leads to the quadratic formula. Okay? All right. Go ahead and practice. See you next time.